do some evaluating of logarithms. Ooh, advanced. Oh, I feel so special. Okay, so what I'm going to do right here is I'm going to put the log of 8 of 1 equals x, and then I'm going to do the old around the world thing. So we're just going to change this from a logarithm to an exponential function. Here we go. 8 to the power of x equals 1. Now there's something special about any number, like any base, to the power of 0. Any base, when I say base, it's going to be a number bigger than or equal to 1. Okay? Anything to the power of 0 will always equal a 1. So I know that in order for this 8 to somehow make itself into a 1, I know my x value right here has to be what number? A 0. So therefore, right here, if I wanted to type in the correct answer, I would type in a 0. All right, so I'm going to type in a 0. I'm going to hit check, and voila. I got it right. Now, here we go. Next one. It's kind of hard to see, so I'm going to go and rewrite it a little bit bigger. The log base 81 of 1/3. I'm going to put equals and x. So I'm going to rewrite this. Okay, so how am I going to rewrite it? 81 to the power of x equals 1/3. Now, let me explain something to you. We are actually going to change everything in this problem to a base 3. So I got to convert this 81 to a base 3. Now, if I knew this, I made a little chart in my journal. I could say, ooh, I know 3 to the power of 4 is the same as the number of 81. And if I made my little chart, all right, of powers, I know that 1/3 can also be converted to 3 to the power of -1. Okay. So now that these bases are the what? They're the exact same. Now I can simply set this equal to this. Well, what can I do with these powers? What am I allowed to do with those powers right there? I'm allowed to multiply them. So what you're going to do, you're going to say 4x equals -1. And then you're going to divide both sides by 4. And you get x equals -1/4. Now, some of you may be watching this video like, what chart is he referring to? This is so confusing. Well, I'll make an example of just base 2, right? 3 to the 0, 3 to the first, 3 squared, 3 cubed, 3 to the fourth. If you're one of my students, in your journal, you would be asked to write a chart, and you'd be all frustrated. 3 to the 0 is 1, 3 to the power of 1 is 3, 3 squared is 9, 3 cubed is 27, 3 to the power of 4 is 81. So that's what I use to go from this to this. And then over here, 3 to the -1 is 1/3. 3 to the -2 is 1/9. 3 to the -3 would be 1/27. Okay? So that's why, what else did I use? I used that right there. So if you had like a list of these in a journal or on a piece of paper, it could really help you while you're working. Okay? So what am I going to type in here? I'm going to type in a -1 divided by 4 and hit check. Hey, got it right. All right, next problem. Ooh, log base 16 of 8 equals what? So I'm going to write a little bit bigger. Log 16 of 8 equals, I'm going to put x. I'm going to rewrite it. 16 to what power equals 8? Now, what can I get an 8 and a 16 to that has the same base? I'm going to convert this sucker to base 2. And I'm going to convert this sucker to base 2. Now, what's already sitting there? So what? N x. Now that I have the same base, base 2, right? What can I set equal to each other? I can set the 4x equal to the 3. Does everybody understand that 2 to the power of 4 is 16, and 2 to the power of 3 is an 8. So what am I setting equal to each other? 4x equals 3. Divide both sides by 4. So what's my value for x going to be? 3/4. There's my answer.
All right, so I'm going to type in 3 divided by 4, and voila. Got it right. Ooh.
And last one. Here we go. Last one before we move on to the next topic. Going to write log 4 of 1/2 equals x. So I'm going to go around the world one more time. 4 to the power of x equals 1/2. What base do you guys think I'm going to use on this one? That's right, base 2. You're right. I'm going to change the 4 to a 2 squared. I'm going to stick the x right next to it. And I'm going to change the 1/2 to 2 to the power of negative 1. Because 2 to the power of negative 1 is 1/2. And if you make your chart, you would know that. So that's the 2. And that's the 2. So what are we allowed to set equal to each other? 2x is equal to a negative 1. So I'm going to write that down. 2x equals negative 1. Divide that by 2. Divide that by 2. Those cancel out. What's x have to equal? Negative 1/2. And voila. You are done.
All right, so here we go. What number am I going to type in? Negative 1 divided by 2. Yay! Woohoo! Got 100%. All right, here we go. Next one. Oh, not that. Go back. Assignments, we're going to go to relationships between exponentials and logarithms. There we go. Bum, 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 bum. All right, here we go.
Now, oh, you do?
No, I had an instrument.
You did? Okay, cool. Now, let me explain to you guys something, okay? Now I have to come up Arnold Schwarzenegger feels kindergarten. All right. So here's what I want you guys to do. Before we do this problem, we're going to do a little bit of investigating using this thing called decimals. So see if you guys can actually let's use our graph and track that pretty fast. So y equals, if you would, this is y equals. We're going to type in 2 to the power of x. All right, type in 2 to the power of x. And then you're going to go down here and you're going to hit alpha window number 5. And you're going to make it a base 2. And then value of x in the parentheses. So get those right there just as they appear. You need to pause this video, feel free to pause it, or mute me if you don't like it. First thing I want you to do is I want you to hit zoom 4. We're going to take a look at these graphs right here. Now, these graphs are inverses of each other. Okay? So y equals 2 to the power of x is the inverse of y equals log base 2 to the power of x. How do I know that they're inverses? Because what are they going to reflect across? What line do they reflect across? You may know. Y equals x is right as he yawns. That's right. So it reflects across y equals x. So the values that are in this table will be inverses of the values that are in this table. Okay? So we're going to check our table now. Check it out. Evident. This one has a what? A 0 and a 1, but over here this has a 1 and a 0. Now it's kind of hard to see the pattern here, so we're going to just take a few points in blue. We're going to take a few points in blue and compare them to the points that are in red. And then we'll do our problem. Okay? So right here, in this one we have a what? A 0 and a 1. And in red, what does it go with? 1 and a 0. Okay? So this one has a 1 and a 2, but over here this one has a 2 and a 1. Hopefully you guys are starting to see a pattern here. What does 2 go with in blue? 2 goes with what number? 4. And over here, 4 goes with a 2. Hopefully you're recognizing that. If you're not able to recognize that, I'm going to go ahead and highlight the blue ordered pairs we're looking at. Right there. There's the blue. And then the red ones are the 1 and the 0, the 2 and the 1, and then the 4 and the 2 right there. Does everybody see how those numbers have been inverted? Okay, so let's go back to our problem. Okay, let's check this out. This one says what? 0.631, and that goes with a 2. This goes to 0.631. this says 3 and a 1, so over here there would be a 1 and a 3. Okay? This says 6 and 1.631. So what do you think I'm going to put right there? 1.631. Okay? Now that says a 2 and a 9. What number do you think I'm going to put there? A 9 goes with the 2. So these right here, now here's a little thing that lets you know. Guess what? You do not need a calculator. What should you know about exponential functions, the relationship between those two? What's the phrase that says they are inverses? That's all you got to do. All right, so let's type this in. Now, if I get it wrong, you get to all laugh at me, okay? But if I don't get it wrong, then, well, you don't get to laugh at me. All right, so here we go. 1.631, right? I'm going to type it in. 1.631. And over here, what am I going to type in? A number 9, 9. Woo! And you got it. Ooh, look at this. It says what? Based on only these 5 points, plot the 5 corresponding points that must be on the graph of y equals log base b of x. So, by the way, see that ordered pair? What's that ordered pair? Right there. What's that? 0 and a 1. So where am I going to put that? 1 and a 0. What's that ordered pair? 1 and 2. So I'm going to put a 2 and a 1. What's this ordered pair? 2 and 4. So I got to do a 4 and a 2. What's that ordered pair? 3 and an 8. So what do I got to do? What do I got to do? Yes, 8 and 3. Thank you. And last, but not least, a 4 and a 16. So what I got to do with this dot? 16, 4. Hey, can you guys see the curve? What does that reflect across? Y equals x. Woo! Man, we are awesome. Okay? Ooh, rewrite the following equation in logarithmic form and rewrite the following equation in exponential form. This is the last one I'm going to do. All right, I'm not going to do all of these for you. All right, but we are going to do some rearranging. All right? Now this one I believe is the easiest for you guys to do because I taught you how to go around the world. So this one's going to be what? 8 to the power of 3 equals 512, which is one of those numbers that should be in your chart. Okay? Now, everybody, I'm going to make some labels here. This is your base. This little tiny number right here is your exponent. So if I'm going to change this to logarithmic form, I'm going to put b, put y equals x. So this right here, this is your exponent. This right here is your base. Okay, so here's what I'm going to write for my answer. Log, what's my base? 0.25. All right, what's my number going to be here? A 2. And what's going to be to the power, what am I going to say it's equal to? A negative 2. So I'm taking my exponent and putting it there. I'm taking my base and putting it here. And whatever that number is right here, that answer right there, I'm going to put it right there for y. So that's how I'm going to rewrite it.
All right, here we go. Going to start with this one. It's the easiest. I'm going to type in 8 to the power of 3, and then right arrow equals 512. This one, I'm going to type in log. And what's our base that I'm going to type in there? A 0.25. Okay. And then I'm going to do, let's see here, put a 2 right there. I'm going to hit a right arrow and put equals negative 2. Now, if you wanted to check this before you hit enter, if you wanted to check it, how could you check it? Does 0.25 raised to the power of negative 2 equal a 2? So you could go to your calculator real quick and just type it in. See if it works. Ready? Is 0.25 raised to the power of negative 2 actually equal to a 2? Hold on. Ooh. What's wrong? 0.25 raised to the power of negative 2. Wait, that should be a 16. Hold on. See what I did. Let's go back. Oh, you know what? What is 2 to the power of negative 2? That's equal to 1/4. I guess I did. Hold on. So if I have 2 to the negative 2 equals 1 over... Oh, hold on. There we go. It's supposed to be log base 2. My bad. Okay? I got things mixed around. All right? Oh, there we go. I messed up. All right. That'll do it. Erase, erase, erase. Hey, by the way, it's a good thing I did that because I was able to check my answer. Okay? So right here, it's supposed to be 2 to the negative 2 equals 1/4. This is the answer. This is the base. My apologies. I got a little rushed. All right? So we're going to write log base 2 of 1/4 equals negative 2. That's going to be your final answer. So here's your final answer. Log base 2, 0.25 equals negative 2. Because 2 to the power of negative 2 equals 1/4. So always check your answer before you type it in. All right? I'll go back. Delete, 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 delete. A 2. Parentheses. 0.25. Right arrow equals negative 2. Now this one works. 2 to the power of negative 2 is 1/4. I'll go back.
Yeah. All right, we're going to do a quick little example on the board. All right, so here's the first one. I want you to write this. 10 to the power of negative 3 equals negative 2. Negative 2. There we go. Equals 0.01. That's the same as saying 1/100. Okay? And then the other one was log base 3, 729 equals 6. So this one's the easy one. 3 to the power of 6 equals 729. You go from logarithmic form to exponential form. Okay. What made this one tricky? How did they start? They actually did what? 0.01 equals 10 to the negative 2. This is your base. That's what I messed up on because I wasn't paying very good attention. That's the base. This is the exponent. So when I do a logarithm, that's the base. This will always be the exponent. And that will be your answer. Okay? So I'm going to write log base 10. What's my final answer? 0.01, right? Or 1/100. 0.01. And what am I raising that to the power of? A negative 2. So this is going to be your final answer. Because 10 raised to the power of negative 2 equals 100. That will be your final answer. For this one, it's going to be what? 3 to the power of 6 equals 729. That's going to be the other answer. So we went from logarithmic form to exponential form. We went from exponential form to logarithmic form.